Hello, Miss Sanders Mathematicians, coming to you with another video. We are still in No Substitute for Hard Work, evaluating algebraic expressions. We are now on activity 1.2. All right, so to earn money for a summer mission trip, Levi is working to help out around his neighborhood. Levi has been hired to build a wooden fence. He plans to use a post hole digger to dig the holes for the post. Okay, so he has basically a contraption that's going to dig these holes for him. Levi starts the project on Saturday morning, but because of the type of soil, he only starts the holes, fills them with water, and then plans to return on Sunday to finish the job. When Levi starts on Sunday, each hole is 3 inches deep. Each time he uses the post hole digger, he extracts 2 inches of soil. The height of the soil in the hole with respect to the ground level can be modeled by this linear expression, -3 minus 2n, where n is the number of times that Levi extracted the soil with the post hole diggers. So what we're going to do is we're going to determine the height of the soil in the hole as Levi works. So these are the number of soil extractions that we have, and then here we're going to use that equation, -3 minus 2n, to figure out the height of the soil in inches. So I have my scratch paper, but if you want to do it over here, you can. So when I start to run out of room, then I'm probably going to use my scratch paper. So the first thing I have here is the number of soil extractions. This is going to be my variable, and in my expression, my variable is the letter n. So every time I see n, I'm going to plug in one of those numbers, and I have to do 1, 2, 3, 4, 5, 6, 7 different equations with the same expression. So let's get started. So my first one is -3. Let me start with my expression so we'll know. So -3 minus 2n. So instead of the n, I'm going to put a 0 because that's what n is. These are all my n's. So now I'm going to solve this. Remember, when you do PEMDAS, you have to do multiplication first. So -2, and if you want to change this to a plus sign and then this to a negative, you can with the keep, change, flip. But -2 times 0 is just 0. And then anything that you add to 0 is just itself. So the answer, -3 plus 0, is just -3. So that's our first one, -3. All right, I'm going to draw a little line so I won't get mixed up. So my next one, still using -3 minus 2n, but this time instead of the n, I'm going to write a 1. I'm going to multiply times a 1. And you can either put in parentheses or just put the multiplication sign. So -2 times 1 is -2. And then -3 minus 2 is -5. So that's this one. And if you want box your answers, I'm just so used to doing that. So I'm going to go through and do number 2 and then number 5, and then you're going to do the rest of them on your own. In fact, I'll be nice. I'll do number 15, and then you can do the rest of them on your own. So -3 minus 2 times, this time we're substituting n for 15 because that's how many I have down here, 15. So -2 times 15 is 30, and that's a minus. And then when you put 2 minuses together, you're basically just adding them together. So -33. So I want you to go through, fill in, finish doing it. Use scratch paper if you need to. So you need to do 2, -3 minus 2 times 2, -3 minus 2 times 5, -3 minus 2 times 10, and -3 minus 2 times 20, and put your answers there in that box. And then you should pause this video so that you have time to do that. And then we're going to come back and we're going to answer some questions. So at this time, you should have paused your video. You should have your answers. to your graph. And now we're going to go ahead and answer the questions from the answers to the graph. And I'm going to go ahead and give you the answers because we have to check our answers in order, or we have to know the answers in order to be able to answer the question. So you should have got -7, -13, -23, and then this one's -43. So hopefully you notice that this is doing what? Hopefully you notice this is decreasing, because as negatives get bigger, they are decreasing. If they were positive numbers, they would be increasing. So let's go over here to number 2. Our first question is, from his research about digging post holes, Levi knows that each post must be placed at a depth that is 2 feet below the frost level, and the frost level is 16 inches beneath the ground level. So we want to know, how deep must Levi dig each hole? So they gave us a formula, and we're going to use that formula. -3 minus 2 times n. And it says that the frost level is going to be 16 inches beneath the ground. So we are going to take 16 and we're going to replace it for n. Two times 16. I do not know that by heart, so I have to come over here or on my scratch paper. Make sure I did that right. 6 times 2 is 12. And remember, I still have my multiplication chart over here just in case I need it. 2 times 1 plus 1 is 32. All right. So now I have -3 minus 32. And now I'm going to subtract those together and I get -35. So now it says determine the minimum number of soil extractions for each hole. So now I have to think about, well, if they're going to be 2 feet below the frost level, and the frost level is 16 inches beneath the ground. So now I have to kind of think, well, if I continue to build them, what is the minimum number of soil extractions for each hole? And remember, the soil extractions was here. And I want them to be at least below -35. So I got to figure out how many extractions would I have for them to get there. I can't wait for you to tell me. So make sure you figure that out there. Now it says Levi's mom, Maggie, uses a cable tool to rig 2 deep wells during a mission trip. Her rig can dig 12.4 meters of hard rock per day. When Maggie starts working on a well, the hole is already 33 meters deep. So we want to write a linear expression for the height of the hole with respect to the ground level for the number of days that Maddie runs the rig. And so I'm probably going to stop, but I want you to try before the timer runs out to see if you can create an expression. And remember, an expression has a number, it has an operation, whether we're adding or subtracting, and then I have a variable. So, and sometimes that variable has a number in front of it. So I want you to see if you can find the number, just like we did here. Find the operation, are we adding or subtracting, and then the variable, the number next to the variable. Can't wait to see what you come up with, but we're definitely going to discuss together. Then once you do that, use your expression to determine the height of the holes after each number of days. So after 2 days, after 5 days, and after 2 days before she started. So this one's 2 days after she started, 5 days after she started, 2 days before she started. So think about before, what that would look like, what kind of number that would be. All right, I cannot wait to see what y'all come up with. That concludes activity 1.2. And we will discuss your answers once you finish. Bye.